Hi everyone, this is the demonstration video of Task3.3D of SIT210. In this task, we need to build an embedded system using an Arduino device and one LED which sends wave signals using ultrasonic sensor. So before moving forward, let us have a glimpse of hardware. So as I mentioned earlier, we are using LED, ultrasonic sensor, Arduino Nano to perform this task. As you can see, I have connected the ultrasonic sensor to the Arduino Nano using breadboard and jumper wires. The VCC and ground pin of the ultrasonic sensors are connected to the VCC and ground pin of Arduino Nano respectively. Trig and echo pin is connected to D2 and D3 pin of Arduino Nano. This was all about transmitter part. Now coming to the receiver part, here I connected the LED to the VCC and D2 pin of Arduino Nano using breadboard and jumper wires. Now this will receive data from the ultrasonic sensor using MQTT library. So when I bring my hand closer to the ultrasonic sensor, the LED will start blinking, and the threshold distance to trigger the LED is less than 12 cm. Now let's come to the software part behind this project. Alright, here is our Arduino code. We start by including the necessary libraries for the board and MQTT client. We have defined our Wi-Fi credentials, SSID and passwords. Next, we specify the pin number to which an LED is connected. We will use this LED to demonstrate how we can control it remotely. We initialize Wi-Fi client and an MQTT client object, which we will use to handle Wi-Fi and MQTT communication. Then we set up the MQTT broker's address and port. Moving on, we are connecting to Wi-Fi, waiting for the connection to establish. If it fails, we retry every 5 seconds. Once connected, we connect to the MQTT broker. If that fails, we are stuck in a infinite loop. We also subscribe to a specific topic, that is Arjun wave, to listen for incoming messages. In our main loop, we are continuously checking for incoming MQTT messages. When we receive one, we parse and print its contents. And here's the fun part. When we receive a message, we blink the LED to visually demonstrate the message reception. Now coming to the second code. Again, we set up the Wi-Fi connections, and next we are setting up our MQTT connection. We specify the MQTT broker's address and port, and the Arduino will connect to the broker using this information. MQTT is a lightweight communication protocol often used in IoT projects. Now let's talk about measuring that distance. We use the ultrasonic sensor to send and receive signals. By measuring the time it takes for the signal to bounce back, we can calculate the distance to an object in front of the sensor. We check this distance periodically. When the distance is less than 12 units, we want to send a message to our broker, MQTT broker. This could indicate an object nearby. We create an MQTT message with the distance data and send it to the broker for further processing. The Arduino continuously loops through this process, checking the distance and sending MQTT messages as needed. We also use MQTT polling to keep the connection alive. And there you have it. We have built a simple IoT distance sensor that can communicate over Wi-Fi using MQTT. So this is all about the project I have made for this task. Thank you so much for watching the video.